Hello everyone, today is hyperbolas. Just to connect it, a hyperbola to an ellipse. Ellipse was adding a constant sum to make the shape, and so because a hyperbola is kind of an ellipse flipped inside out, we're going to subtract those same two distances. So when we add these two distances, the ellipse is formed. When we subtract them, the hyperbola is formed. So it's basically formed the same way, and that's kind of important to know because that's how we graph it. The graph is really not going to feel too much different. How you count, where you start, the names of things, all the same. So really closely connected to the ellipse, which is a good thing because that means you kind of already know what's happening. Obviously, the graph looks crazy different. So your process is the same, right? You'll start at the center, which is here, and then you will count one direction to find a vertex, right? Same with the other side, so this is a vertex. Then you'll count the other direction to find the co-vertices. We'll talk about which one's which here in a minute. And then after that, you use those points to make this rectangle. The only reason we need the rectangle is because you need the diagonals to form the asymptotes, because we don't really plot points. We just say, oh, there's an asymptote. Okay, so now I know how to draw the graph. And so that's how the actual curve will be formed. So the rectangle, the diagonals, draw the curve. Now the focal points are still inside the curve, so they're real far away from the center. So this is still going to be the distance of C. It's just bigger. It's actually the biggest, bigger than A. So it has a little bit of a different feel to it. Same thing if it goes the other way. Of course, the focal points are here and here. And then your vertices are in that same line. So this is still your major axis. We don't call it that. We actually call that the transverse axis now, but it's still like the place where all the things are, the focal points, the vertices in the center. Then we have a name for the other axis. It's called the conjugate axis. Conjugate, and we'll go over this here in a second. And the conjugate axis just has the co-vertex and the other co-vertex on it. And of course, it also goes through the center. So the center is actually, just like it's always been, it's the midpoint of the foci. It's also the midpoint of the vertices and the co-vertices. So that's exactly the same. Your vertices, or where the graph actually turns, this is controlled by plus or minus A, just like in an ellipse. The co-vertices are controlled by plus or minus B, just like an ellipse. Now the transverse axis, we used to call this, or in the other shape rather, it's the major axis. So it's the one that has the vertices on it, and this is of course 2 times A. Conjugate axis, this is what we used to call minor, or we called it minor in the ellipse, and then this is of course 2B. Here's what I was telling you about the asymptotes. They're just the guidelines to draw your curves, and the focal points are still plus or minus C away. Now the formula is a little bit different. You have that on the formula paper, but I'll put it here as well. To find C, this is C squared, but we're going to do A squared plus B squared. It looks like the Pythagorean theorem, but it's not applying to the Pythagorean theorem. We're not talking about a triangle, so it's not the Pythagorean theorem because A, B, and C are different than they would be for that. Most important thing about the standard form is that A squared is first. It's not bigger, it's first. So in a hyperbola, order is super, super important. The top will look the same, x minus h quantity squared. This is a minus sign, also kind of a big deal. Y minus k quantity squared. The minus sign comes from the definition, so that's why I started with it. So in this case, if it's running straight up, and if it's running left and right, because this lines up with up here, a squared would be underneath the x squared. You graph it the same, so whatever's underneath x, that's the space you go left and right. Whatever's underneath y, that's the space you go up and down. Now, if it's oriented the other way, and we keep this the same, we would have x minus h quantity squared minus y minus k quantity squared. But now, a squared would be underneath the y. And so that's the difference. And then we'd have b squared here. So it's not bigger. Sorry, I'm doing this like an ellipse. It's first, so we got to switch the order. Let me back this up. So if we have to switch the order, remember a squared would be first. And if we wanted to run the other way, then the y would have to also be first. And then x minus h would be here with the b squared here, because a squared is first. Now, you got to be careful with this because you will have to read your center backwards. The center is still x, y. It's not necessarily left to right. I put the steps for graphing underneath there. The steps for graphing are very much the same as they were for an ellipse, but in case you need that reference, there you go. So as expected, they will ask for the exact same things that you were asked for before. Start with the center. It's the best place to start. Here we have no numbers on the top, so the center is 0, 0. I'm going to put that on my graph, so I just remember I got to count from there. Now, a squared is first, so a squared is 2, which means a is plus or minus 2. Now, that falls underneath x, so we go left and right 2. These are the vertices. This matters because this is how we're going to draw the graph. So the vertices are negative 2, 0, 2, 0, which you could write plus or minus 2, 0 if you want to. The co-vertices, of course, go with the other one. That's going to be your b squared, so that's 25. So b is plus or minus 5. So from the center, we're going to go up and down 5. And then the co-vertices, of course, the coordinates are 0, up and down 5. Now, the ellipse lives right there, right? So the ellipse is still there, but we're not drawing the ellipse. You can if you want to, but it's extra. We're going to use these points, and these points, let's see if I can draw it so you can see it, are basically the midpoints of the sides of the rectangle. So drawing the rectangle sometimes is a little bit awkward. Once you get the rectangle drawn, then just draw in the asymptotes. This is the part that, you may get it, you may not. Ooh, mine was kind of bad. Hopefully yours is a little better than that. But you're trying to hit the corners, the center on each diagonal. And now when you go to draw this in, it's drawn in based on the first letter. So since the first letter is x, you draw it from x, which means left and right. If the first letter was y, it would go up and down. So now the focal points. Just like before, you're asked for them, you do not need to graph them, but now we have a different formula. C squared is going to be a squared plus b squared, or just add the two bottoms together. It doesn't really matter which one's a and b when you do this because you're adding. So we're going to have c squared equals 4 plus 25. So c squared is 29, and we take the square root, of course, get a decimal. So that's plus or minus 5.4. Now remember, the focal points are actually still inside the curve, just like they have been. It's just farther away. So we're going to go left and right, 5.4, and we don't go up at all. So if you need to kind of eyeball that sketch, you can do that if that helps you visualize how to write the coordinates. You do not need to graph them. In fact, I just put them on there. They're probably not even in the right spots, but just to kind of show you where they would be. Just another graph. Again, this looks maybe funny. If you don't like that, put the 1 on the bottom. I just wanted to show you one that has a 1 in it. You can write it or not write it. Your center goes x, y, so 3, negative 1. I don't like this goes the same way, but oh well. And so from the 3, negative 1, there's our center. A squared is first. A squared is 16, so that means A is plus or minus 4. So in the direction of x, from the center, you go left and right 4. These are your vertices, the coordinates of these points, negative 1, and looks like 7, negative 1. Co-vertices, b squared is 1, so that means b is plus or minus 1, so up and down 1. So this is a skinny little rectangle. The co-vertices are 3, 0, and 3, negative 2. Let's draw that rectangle. Again, do your best to kind of eyeball that. All right, so oops, I kind of missed that one, but here's the rectangle. Please draw the rectangle, please, please, please. Now the asymptotes also must be drawn. It doesn't matter to me if you draw these dotted or solid. They're supposed to be dotted because they're not really the answer to the graph. The answer to the graph is these curves right here. I just did them in different colors just because I think maybe that different color sort of shows up better. Yours obviously should probably be all the same color. And there's the graph. Focal points, c squared is add up the bottom, 16 plus 1, which is 17. So we take the square root of that, and you get plus or minus 4.1. And again, this is going left and right. So the center is 3, -1, and we're going to add and subtract 4.1. If that helps you kind of set it up, please do not leave it like this, because you can actually do the adding and subtracting. So 7.1, -1, and 3 minus 4.1 is -1.1, and then of course -1. Standard form, minus has to be in the middle. Has to be. Order matters. So you don't have to think about it too much until the very end. I'm going to set this up like I normally would. I'm going to put the x's together, and I'm going to put those together first. So I have 9x squared plus 90x minus 16y squared equals 351. You have to factor, so we're going to factor out the 9. X squared plus 90x. Oops, that's not factoring. You got to divide, sorry. X squared plus 10x. When you complete the square, you do it inside. This is a good sign. The -16, the negative sign is second. And then over here, we're just completing the square once, so we have only one number. Half of 10 is 5. 5 squared is 25. Now remember the trick. You really have to go 25 times 9. That's 225. And that's going to go over here. Now the way you know you did this correctly is like an ellipse. When you add this up over here, and I'm going to do that first, we get 576. Basically, 16 and 9, if they both divide evenly into this number, then you did it correctly. We will not have any that do not divide evenly, so that's a good way to check if you've done the numbers correctly. So then we have 9x plus 5 quantity squared minus 16y squared, and now of course we go back and divide everything by this 576. So we get x plus 5 quantity squared on top of, now remember, divide the 576 divided by 9, that'll give you 64, minus y squared, do 576 divided by 16, that's 36, equals 1. Now for number 5, we want the minus in the middle. This y squared is on the other side of the equal sign, so I'm going to add this or bring this over. The x squared is going to stay negative, so x squared should be second. So we're going to have y squared minus 6y minus 4x squared minus 56x equals 287. We don't have to factor anything out of the y's, but you have to factor out a -4. This changes the sign. So -56 divided by -4, that's going to be a plus 14. Complete the square inside there, and then we have 287, which I know is a weird number, but that number is there to help the problem work. Half of 6 is 3. 3 squared is 9. We don't have a number out there, so we really are going to add 9 over here. Half of 14 is 7. 7 squared is 49. And now you take 49 times -4. So this is a -196. So again, I would do this arithmetic this side first, just to check it. This equals 100. And 100 does divide into 4 evenly. Obviously, it divides into 1 evenly, so we're good there. So we have y minus 3 quantity squared minus 4. X plus 7 quantity squared. You go through and divide by that 100. This will force that to be a 1. So we get y minus 3 quantity squared over 100 minus x plus 7 quantity squared over 25 equals 1. I'll just do this one last one if you need to stay tuned and still watch it. We're at the same situation where this y squared is on the wrong side of the equal sign. So the y squared is going to be added, which means the y squared is going to come first, I guess, again. So 4y squared, then you get the other term with the y, negative 9x squared, then the term with the x, and then, of course, this 104 is going to stay put. At the factor of 4 out of the y family, so we get y squared plus 16y plus something. And this is the part you got to be careful with. Take out the negative 9, that's x squared, and then a minus 4x. That sign changes the center, and we do everything from the center. So if your center's wrong, your whole graph is going to be wrong, which is unfortunate. Half of 16 is 4. 4 squared is 16. Remember to take that times the number out in front. 16 times 4 is 256. Half of 4 is 2. 2 squared is 4. 4 times negative 9 is a negative 36. I'm going to add this up real quick. We get 324. I'm also going to check. 324 divided by 9 works. 324 divided by 4 works. So it looks like we're okay. So 4 is then y plus, okay, this isn't right. This is a 64. And then 64 times 4, that's where that came from. Sorry, I had the wrong number. I knew it was 256 over there. But this is really an 8, because I can take half of 16 apparently. And then minus 9, x minus 2 quantity squared. We're going to go back and divide everything by 324. So this will be y plus 8 quantity squared over 81 minus y minus 2 quantity squared over 36 equals 1.